So in our Jupyter notebook, let's investigate how wrong and how useful our house price model is. And we'll commemorate this with a new section heading. I change this to Markdown here and put 2 hashtags there and write residuals and residual plots. And now what I'm going to do is I'm going to take some of our existing code and just copy it below. We're going to reuse some cells, but modify them a little bit. So I'm going to take this cell right here, copy it, scroll down, and paste it in. And I'm going to add some comments here. So I'm going to call this one modified model transformed using log prices and simplified, dropping 2 features. Now, just because I put that in the comment doesn't mean we've actually done it. So I'm going to come here, and on this line, we're not just going to drop the price, we're going to put some square brackets around price, then a comma, and then we'll drop 2 other features that we had earlier, industry and age. Now let me come in here and delete this part of the code. I'm going to hit Shift Enter, and now I'm going to add another comment here that reads using stats model. So instead of our scikit-learn, we're going to continue using stats model here for analyzing our residuals. Next, I'm going to come up here, take these 3 lines of code, copy them, and paste them in here. Okay, so now we're all set up for this lesson. Now we can start looking at our residuals. So I'm going to add a comment here. We said the residuals are equal to the difference between our observed values and our fitted values, or our predictions. So the observed values y were y train, and from y train we can subtract the fitted values. We can find these under results dot fitted values. Let's take a look at what these residuals actually look like. So residuals and Shift Enter will split and shuffle the data, train the model, and then output our residuals. And here we go. These are all 404 residuals from our model. If you're wondering what type of object we're working with here, then we can see it is a pandas series. That's quite nice, because if it's a pandas series, we can call a bunch of methods on it that the series has, like describe. And if I do that, we can see that the mean of the residuals is very, very close to 0. But more on that later. So let me quickly comment this out, hit Shift Enter, and show you that you don't actually need to do this calculation manually, because our results object from our stats model actually already has an attribute which allows you to fetch the residuals. So results.resid is the name of said attribute, and hitting Shift Enter, we get presented with exactly the same thing. All right, let me comment this code out again. Scroll down a little bit, hit Shift Enter, and get to the interesting part, namely the part where we are graphing our stuff. So I'll add another comment here that reads graph of actual versus predicted prices. Now, before I write this code, let me explain the rationale of what I'm about to do here. I want to create a chart that visualizes how good our predictions are. I want to see how our predictions actually stack up to the actual property prices. Because seeing this picture will put the R² from the regression that we calculated into context. If you remember from our earlier lessons, that R² was kind of a nice one-number summary for our regression. But it's definitely not the only thing that we should be looking at. Now let me ask you this. on this chart of the actual versus the predicted prices, what would this chart look like if our model was perfectly accurate, if it had like perfect predictive capabilities? What would you expect to see? In that case, you'd expect that the predicted prices are kind of a really, really close match to the actual ones. In fact, you'd get all of these things lining up on a straight line, right? You should have a very, very strong correlation between the model's predictions and the actual results. Let's calculate this correlation and store it in a variable. So I'm going to say core is equal to y underscore train dot core parentheses results dot fitted values. This here calculates the correlation method on our y underscore train object, and we provide as an argument the fitted values from our regression. Let's output this value here. So I'm going to say core and hit shift enter. The correlation that we see printed out here is 0.89 approximately. That's quite high actually, which is pretty good. I think one thing I'd like to do though is round this value here. So round parentheses and then at the end here a comma and 2. So I'm going to round it to 2 decimal places, close the parentheses and hit shift enter again. Nice. Now let's create a scatter plot using matplotlib, which we've stored in our plt variable. So I'm going to say plt.scatter, parentheses, for the x-axis, we're going to use our y-train, our actual values. For the y-axis, we're going to use our fitted values. So this was results.fitted values. Now, I'm also going to add a color and a transparency to this scatter plot. For the color, C equals, I'm going to go for maybe navy blue, so navy in single quotes. And for the alpha, the transparency, I'm going to go for 0.6. Now let me write plt.show and take a look at what this looks like. Here we go. Now it's a little hard to see what's going on here. I think we need some labels on our axes. And we should also plot a line on this graph that represents the perfect fit. So we have a reference point for this scatter plot. Let me hide this plot by double-clicking in here and updating our code. Now, in adding our axis labels, I'm going to show you how you can include scientific notation or LaTeX notation on the labels themselves. LaTeX notation is something that we've used in our markdown cell, but so far we haven't really integrated it into our charts. So let's do that now. I'm going to have plt x label, parentheses, and then single quotes, actual log prices, and here's the LaTeX notation. $$, and then between the dollar signs, I'm going to have y, and then I'm going to have like an underscore and then an I, meaning this I will be shown as a subscript. And anything between this opening and closing tag will be treated as LaTeX notation. Let me add a font size as well. So comma, font size is equal to maybe 14. Let's see what this looks like with shift enter. Here we go. As promised, we see that y has a subscript. Let's add the label for the y-axis. plt.ylabel, and try this one more time. Say predicted log prices. And for the LaTeX notation, I'm going to say y hat underscore y. And I can do this by having that slash hat for the LaTeX tag. And then again, I'll have y underscore I. And also font size equals 14. Take a look. Here we can see that the hat tag in the LaTeX notation creates this little carry symbol above our y here. Nice. Now let's add a title to this chart. And in the title, we'll use both LaTeX notation and we'll use an F string to show our correlation as well. So plt.title parentheses F single quotes actual versus predicted log prices colon dollar dollar and between the dollar signs y underscore I versus dollar dollar slash hat y underscore I, and then outside that dollar sign parentheses core curly braces and then lowercase corr, which is the name of our variable here. And at the end, of course, we've got the closing curly braces, the closing parentheses for this one, single quotes to finish it all off, and maybe a font size of, say, 17. Let's take a look. Fatal exception. What was the problem? A typo in the LaTeX tag. It should read /hat. There we go. So I think this chart is already starting to look pretty good. The only thing missing is that line that represents perfect predictions. And we can add that up here with plt.plot, plotting a single line. And that line for the x and the y will be the same. So in this case, it would be ytrain, comma, ytrain. And I'm going to give it a different color as well. So color is equal to, say, cyan. That'll make it stand out quite nicely. So check it out. Here we go. This cyan line would represent a perfect prediction. So it goes through all these grid points here. 2 and 2, 2.5 and 2.5, 3 and 3.5, right? And this allows us to see how our predictions stack up to the actual values very, very clearly. The bigger the distance from this cyan line, the bigger the residual. In other words, in this part of the chart, our model is doing really, really well. But for these data points here, we have much larger residuals. Now, what if looking at log prices isn't that helpful? What if you wanted to look at the actual prices, the actual dollar values? Because that's much more intuitive. All we have to do is reverse our transformation, right? So let's create a second chart below this one. I'll take this code here, copy it, paste it below, and then all I have to do to reverse the transformation is raise our data points to the power of e. So np.e times, which raises it to the power, and we do the same thing here, np.e, raise it to the power of our residuals. And of course, we have to do the same thing here, np.e times, np.e times, and then actual prices in the label, predicted prices in the label, and then for the title, we'll also do that. To differentiate the two charts visually, I'm just going to go with straightforward blue for this one. So our scatter plot here will just be blue. Shift-Enter updates what we see. And now our axes are transformed, and we see our dollar prices in thousands. We can even add that to the label. So actual prices 000S. And here predicted prices 000S. Shift Enter. And now our labels are updated. Now that we've got our charts pretty much where we want them to be, we can start to interpret what it is that we're looking at. How do you think our predictions are stacking up to the actual values looking at these charts? I think we're doing actually rather well. And what we're seeing here pretty much ties out with the expectations that we had looking at the high R-squared. A lot of the predictions, in fact, are very close to this cyan line here. Mind you, this sign line is not the best fit line for the scatter plot. The line here shows where our points would have to be if our predictions were perfect and our residuals would be equal to 0. The sign line represents where y hat would be equal to y. But looking at this chart, I do see something that kind of concerns me a little bit. Take a look at this top right corner here. There's definitely something kind of strange happening with the properties at the very top price bracket. These are the properties at the $50,000 mark. Here we can see that our residuals are actually fairly large, and our model is performing quite poorly. If you remember, we actually visualized all our target values in our data exploration stage, and there we already spotted that there were quite a few properties at the top end of the price bracket, and that given this histogram, these kind of struck us as outliers, and we suspected that maybe these might cause an issue down the line. What I'm saying is that, yeah, there's room for improvement in our model, obviously, but overall, I think I'm pretty happy with what we've got so far. After all, we're dealing with a real data set, so it's nice to see things line up to the extent that they do.